Today we're going to go over the different offset methods that we use with the laser in a GIS mapping type scenario where we want to put coordinates on that water meter out in the middle of the roadway there. We don't want to occupy it. Got some traffic in the area, so we're going to get off here on the safe position and we'll show you the different methods you can use with a laser to put a coordinate on that facility. Okay, for the first method, Range-Azimuth, it's the simplest actually. You just need one known coordinate. We're going to simulate it here using GPS to get our known coordinate, and then you measure azimuth, inclination, and distance all with one shot to the target. So for this Range-Azimuth method then, you've got the GPS to get your known point, you've got the model 360R to get your range and azimuth, and then a tablet with your data collection app running. So you just log your GPS point, take your shot to the object, all that data feeds through, and you've got your remote coordinate. If other measurements are needed for this one location for Range-Azimuth, you can just take them down in succession, just single shots to each target and they'll feed through. The next method we'll discuss is our range method, distance. And we'll get our known coordinates with GPS, and we've got our tablet here to run our app. For this, we'll just use the 200x laser. It'll measure distance and inclination for each of our shots. So the first thing you want to do is to log your first position nearby the target. So we'll log that with the GPS, and then we'll take our first distance and inclination to the target. We've got that logged, we're ready to move on. We've moved over to our second point now, and we want to create some good geometry between the points. We don't want to have our control points too close together or the feature too far away from them. So we've come to a good spot here. We'll log the point with GPS, and we'll measure our distance and inclination to the target. And we've got that done. So now we have two known points and two distances to our target. That creates essentially two intersecting circles. And we just tell the software which side of those points we're on, and we've got our remote coordinate. So the final method we're going to talk about is the range angle method. This uses our true angle encoder, which does not have any susceptibility to magnetic interference. It's immune from all that. You can use it in crowded urban settings without a worry. It's also got great angular accuracy at 1/10 of a degree too, so another super accurate way to get your offset coordinate. Then you've got the GPS to get your known point, the 200x laser, and then a tablet with your data collection app running. So what we do for this method is we set the system up in a convenient location, and we need to have another point that we've logged with the GPS visible to us. Across the street, down the road, something like that. That's going to be our reference point. Between these 2 points, we can calculate a good azimuth, and then the true angle will just turn a relative angle off of that mark and get to our point. With the other point that we've set and our new point derived from the GPS, we can get that at good azimuth. So now all we have to do is just reference the encoder on that point. It's all good to go. We log our point here with the GPS, and then we turn over and we shoot down to our target. So just a single shot down there of our angle, distance, and inclination, and we can calculate that remote coordinate. So no need to re-reference again, we just continue shooting.